Hi class, welcome to the Thanksgiving week, and we will have a short lesson for this week. Today we're going to focus on obtaining information from the graph of a function. So the first we have the review problems. This question 3 is from last class, so we're going to review this during the next class when we meet. So you can complete this one before next class. We're going to get into our new lessons today. So obtaining information from the graph of a function. We learned from a previous lab that the solve command can be used to find the x-intercepts if there are any. To find the x-intercept of an equation, set your y value equal to 0 and solve for x. The intercepts also helps us to state the intervals where a function is positive or negative. Given a function f(x), it is positive where f(x) greater than 0 and negative where f(x) is smaller than 0. Here, given a polynomial, find the x-intercepts after plotting the function state where the function is positive or negative, evaluating the statements. Okay, so here, execute the graph. So for the function f(g(x), notice for the above function, the function is positive in some area as well as negative in other areas. The function is said to be positive when it's above the x-axis. So the interval for the positive parts are from -infinity to 0 and 3 to infinity. When the function is negative, it's from -infinity to -4, which is this part of the graph, and this part of the graph is from 0 to 3. So let's look up the example 2. So we want to state the intervals where the function is positive or is negative. So execute graph first. So here we cannot precisely say what on the bottom here, how the graph changed. So maybe we can change this plot range to the larger range. Let's change to -30. Also, I'm going to change to -30 to 20. Okay, looks better. So here we can see the part of the graph. This is a vertical line and this is vertical. So when the graph of hx, let me see what's happening here. So graph of hx and consists this part and then this part, then this part. So separate this function into these 3 parts. And there's a vertical tangent here, vertical tangent here. So we want to see where the graph is positive, where it's negative. So the positive is when the graph is above the x-axis. So for the positive, the interval is from negative infinity from -infinity to this value here, -1, and the union from 0 to positive infinity. And when the graph is negative, which is below the x-axis, and it's from negative infinity, this part of the graph, this part. So negative infinity to 0. Okay, so now let's try the number 3. Given px is negative x times x plus 3 times x minus 2, find x and y intercepts. Okay, so let's find x, y intercepts first. So according to this graph, we can say x-intercepts are negative 3, 0, and 2. So in some case, you cannot precisely say where is x-intercepts. Let's say if the point is here, you cannot, it's hard to estimate the precisely number. So in that case, we have to use unsolve command. So let's just use unsolve command to find px. So x intercepts y equal to 0. So we want to find x. So here the x intercepts are, so I would answer the question here. So the x-intercepts are, you could state the x-intercepts as a point or just say the numbers. I would say negative 3, 0, 2. So if you state as point, so we should write as a point negative 3, 0, then 0, then 0, 0, and then 2, 2, 0. So 3 points. So now we want to find the P of 6. So P of 6. P of 6 is negative 216. So here P of 6 is equal to negative 216. Now we want to find px equal to 24. So we use unsolve px. So for x, px equal to 24. So for x. So here we can say x equal to negative 4 and 1.5 minus 1.94i, and x equal to 1.5 plus 1.94i. So both these two are imaginary numbers. So for the real solution, x equal to negative 4. So here if px equal to 24, x is negative 4. Okay, so how many times does the 9 y equal to 5 intersect the graph? So one way we can check how many times intersect the graph is we plot this 9. So let's add this 9 in this on the same set of axes. So y equal to 5. So let's add this one here. Okay, so as we can see here, y equal to 5, the graph of y equal to 5 intersects the graph once. So how many times does the 9y intersect the graph? So only one time. I'm not typing all the sentence, but when you answer it, you're expected to type all the whole sentence. So now we're going to state where the graph is positive, where it's negative. So now we're going to use the intersect here. So when the graph is positive, it's above the x-axis. So it's from negative infinity to -3. This part of the graph is above the x-axis, and another part is from 0 to 2. 0 to 2. And negative is otherwise the graphs are below the x-axis is from -3 to 0, union 2 to infinity. So those two parts are below those two parts, this here and this part here is below the x-axis. So now increasing and decreasing. To answer increase and decreasing, we better to find these turning points here. So sometimes it's easy to estimate the turning points like this one. Probably we say 1. So here is possibly is about negative, a little bit more than -2. So if we want to be precisely what are these two turning points are, we can find the critical points, which will involve the first derivative. So if we want to find the first derivative, we will find the p prime of x, p prime x. So, and we want to find precisely, we want to find unsolved p prime x equal to 0. So this will help us to find the critical points. So which these 2 points is not negative, is not exactly -2 here, is -1.7863. So this side is not precisely 1, it's a little bit over 1. So then this increasing, decreasing the graph, decreasing is from -infinity, this part, to this point, and increase to this point, then decrease. So we have one part interval is increasing, so it's from -1 point, I'm going to keep one decimal place, to 1.1. And the decreasing is from -infinity to -1.8 union. The other one is from 1.1 to positive infinity. Okay. So number 4 is very similar to the question example 3. So I'm going to leave the number 4 for you to complete. Now the number 5, I will give you the example of the number 5. Construct a possible polynomial function with the zeros. So if we know the zeros, we know how to write this as a factor. So let's just consider the zeros first. So if we want to say, I want to make sure is this a polynomial we have, so it's better just to plot this polynomial function. Okay, so with zeros, -1, that means x plus 1, multiply 4, 0, 4, that means x minus 4, and also I have extra here, and also 0, that means x, you could say x plus 0, or you just keep x add 0, doesn't matter. So we're just x. So then we also need to consider about multiplicity too. So what the multiplicity means is their exponents. So how many times this factor multiplied, that means multiplicity. So let's say the multiplicity 2, that means x plus 1 you multiply twice. So that means x plus 1 times x plus 1, which is x squared, x plus 1 squared. So multiplicity 1, that means x minus 1 minus 4 only have exponents 1. 0 zeros multiplicity 2. This also means x times x squared. Okay, so after we have this, we may want to have plot domain and plot range, how we graph. Those are things we need. So let's name the x from -10 to 10 and the range from -10 to 10. We want to see how the graph looks like. Okay, so this is our graph, and the last we couldn't see the bottom. Let's just change this to the larger. I don't know if -30 work, but let's change -30 to 30. Okay, maybe we need more. -50. Huh, 100. We still did not see. Maybe more. Better. So it's 200, 200. Okay, so now last thing we want to check. So the with fx decreasing as x goes to positive infinity. So that means when x goes to right, so goes to positive infinity, but fx is supposed to be decreasing. But in this case here is increase. The graph is increasing when x goes to positive infinity. So this means possibly if we could flip this graph, flip this one. So then this could be go down, and that will become decrease. And remember, how can we flip it? You can simply multiply -1 or negate this function. Okay, so when x goes to positive infinity, the fx decreasing. Okay, so now we complete this. Okay.